That's Integrated Vehicle Health Management. I was a sponsor for a document that was just published about a year ago on health-ready components. I've been helping with SAE trying to get a new consortium going in this health-ready components and systems area, which I think could be very useful to companies interested in autonomous type vehicles. I have two major success cases to mention briefly. One is that I led a team of people who implemented a predictive maintenance system that was put in General Motors powertrain assembly plants around the world, and it saved in excess of $1 billion, so it worked quite well. Also, more recently, GM has begun offering a service for our vehicles called OnStar Proactive Alerts. That system monitors the starting system of those vehicles and can warn customers before problems happen with their starting system. That system is now on over 3 million vehicles in the United States. I'm a life fellow of IEEE, and I'm a fellow of the Prognostics and Health Management Society. My primary message that I hope to leave you with today is that VHM technology, or this advanced analytics or predictive maintenance, whatever you'd like to call it, I think has a role to play and would be very useful in terms of impacting actual field reliability experience.
Good afternoon. I'm Bob Haig. I'm the Vice President of Sales and Marketing at Crystal Group. Crystal Group's a company of about 250 employees located in Cedar Rapids, Iowa. And our business model centers around taking commercial off-the-shelf technology and ruggedizing it for heavy industrial or military applications. Most of our business is in the military space, where we take the same motherboard that might be in your home computer, same network switch, same Wi-Fi router, and we ruggedize it by creating custom packaging. We do things to the board to make it survive in a very rugged environment. And I was telling the team here, we basically got tugged into the AV space here a couple of years ago, as from my personal experience, some of the car makers in particular were doing their algorithm work, their AI work, and realized that worked great in a lab on a laptop or on a server computer, but as soon as you had to put a car in the cold of Detroit or bumping around potholes, railroad tracks, need something rugged in the trunk. And it's been really cool to be able to apply the same techniques that we use in heavy industrial places like oil wells and military, like a tank or a Humvee, realizing that the trunk of a car is a very harsh environment as well too. So our specialties are packaging, putting things together and getting the heat out, because what we've seen across the board is all of our AV customers are continuing to add more cameras, add the latest cameras, add more processing power as they really work on perfecting the AI algorithms. And for us, that means a lot of heat's got to get dissipated. And for us, the most important thing we can do to help on the safety side is make a very reliable product. And as we get into the conversation here, I'll share more of what we're doing from our side, but not only on the safety side, but the security side. And as I close, I also want to thank Courtney, Xponential, and SAE for letting me be on the panel as well.
Hi, I'm John Tintinalli. So I work for SAE International as the Director of Innovation and Business Development, based in the Bay Area, sort of co-located also in Detroit, but sort of weaning that out of the way. My role at SAE, part of this was the Group Product Director for Ground Vehicles. In my recent role, started in February, my job for SAE is to bring what we would consider non-traditional automotive players into the SAE global community, and doing that first in California and then in Europe. Most of my work around SAE centers around the space of automated and connected vehicles and electrified propulsion. Prior to joining SAE, my background was primarily in software engineering consulting, created the first software as a service logistics management system, which was subsequently sold to Landstar and then XPO. Also created the logistics management system for BMW for their Tier 1 supply chain out of Greenville, South Carolina. And I've been working for SAE for about 3 years. And most recently have launched a new consortium, which we premiered at our seminal event, WCX in Detroit, few weeks ago. That's the International Alliance for Mobility Testing and Standardization, which I get a chance to talk to you a bit more about today.
Fantastic, thank you. Just a reminder that it is interactive, so if you have any questions, please feel free to take advantage of the microphone. Let's just start off by diving in and defining reliability and safety. I know that's a difficult thing, taxonomy, but more importantly, how do cities define what's reliable and safe when they evaluate AV car testing? And how does the public define it? Is an improvement on the nearly 40,000 annual fatalities enough, or is the expectation for zero automated vehicle-related fatalities?
Well, can I jump in that?
Yeah, please.
So safety and reliability, that to me, that's one of the most fascinating questions out there because it's almost answered, believe it or not. And hear me out on this. What we're seeing right now is when it comes to the term safety and reliability, every manufacturer has their own regulatory view of what that is for their component, whether it's a LiDAR system, whether it's a camera, whether it's the complete vehicle. But we've kind of gone down, I want to say, a very dangerous path in that safety and reliability has now come to mean one thing, and that's how many disengagements are we seeing on that autonomous vehicle. So even though you have the Department of Transportation and NHTSA with these very good and elaborate frameworks talking about how to ensure the safety and reliability of the car system, we're focusing on this one metric called disengagements. And that metric, as we all know, it starts out with the vehicle, but then it goes down to the individual components that may have caused the car to disengage from an autonomous mode. And one of the issues here is that that's more a risk tolerance metric than it is something that tells you anything about how your vehicle or your systems are performing. And if you look and see what's happened in California, California has adopted that metric. The city of Pittsburgh has not, and that's the subject of another question and discussion. But the point is, I think we have to go back to the basics, and we can't have this metric define which car is safer, which is less safe. If you're from Waymo, you've just been declared the safest AV company in the world. If you're from Apple, you're from the least safe, and that's in the popular press right now. And there are all kinds of permutations in between, but that metric is being used to define who's better, who's worse, whose systems are better, and whose systems are worse.
Yeah, please.
I wanted to just add a little bit of a different twist on reliability. I mentioned that vehicle health management was my primary area. And in vehicle health management, it's really focused on reliability kind of issues primarily. But while everyone up here would agree that the raw reliability, the best you can do, you want to have designed into your systems. But VHM can get you something a little bit more than that if you think about it. Let's say that it's possible to predict roughly 90% of the failures for certain critical components. And that's a pretty good number. You have to work at it, but it's possible. And if you can do that, that is predict in advance while you have time to do something about it, 90% of those field failures, from the user's point of view, that just improved the reliability by a factor of 10. So it's quite a big deal. And so while that didn't change the raw reliability, that component's still going to fail. If it doesn't actually fail for the customer in their actual use case, that's a huge improvement. And that's the principal mechanism by which VHM can have a positive impact on these kind of systems.
That's great. And Bob, I don't want to single you out, but I know that you've spoken a lot and written a lot about how reliability, survivability of systems is intrinsic to safety.
Yeah, so let me add on to what everybody said so far. And as I said in my lead-in comments, as the hardware platform provider that hosts these AI applications, the most important thing we can do is make a really reliable product. That said, we get after reliability, a lot of our customers want dual redundancy until this, and coupled with what we've heard about putting some health monitoring on top. We've got a good solution. Boy, if one side's going out, I can automatically keep running. There's ways to engineer reliability into an AV system. Now, some things we do to improve reliability that are probably unheard of in a lot of the automotive world is We actually put coatings on the board, so when humidity in the trunk is forming, it's not shorting out components. We do some things in the chassis to make sure as it's shake, rattling, and rolling, that board isn't twisting and components are flipping off. So again, from a reliability perspective, the best thing we can do is make a good, reliable product that has ways to let someone know when there's about to be an issue, and I agree that predictive maintenance is a good way to get after reliability improvements and safety improvements.
Mind if I jump in here?
Yeah, please.
One of the things that we've noticed as we've continued to talk to customers in the autonomous space is that because the uptime and the utilization of these fleets and networks will be much higher than current consumer vehicles, the lifetime expectancy of a vehicle in the network would change, right? So right now, most tier 3 or tier 4 suppliers will test materials to a 10-year lifetime. By most estimates from our customers, they're saying that the vehicle lifetime is expected to be about 3 years. So you're going to see this dramatic decrease in the amount of time that a vehicle would need to spend on the road. And that opens up some new material sets that could be explored where we don't have to achieve that 10-year cycle.
Just to make sure that we've covered the topic adequately, is there anything else that we should talk about how we can enhance or ensure AV reliability with VHM or from the get-go with engineering from the ground up to be survivable? And we kind of covered ours. Are safety critical autonomous vehicle systems at risk of failure? How can we ensure, particularly if they take advantage of commercial off-the-shelf technology that are perhaps designed for stationary, temperature-controlled office environments? How do we ensure that they can withstand harsh road environments? From a pothole to a fender bender, rough terrains, etc.
Why don't I jump on that one with a little bit of amplification on some of the comments I made earlier. The commercial off-the-shelf components won't survive as they are, and I think a lot of our customers are experiencing that, and they found us. Now that said, there's a big benefit to using the latest and greatest technology. As I said earlier, more and more of our customers see their AI application growing and growing and growing, and I routinely get asked, hey, I want the latest NVIDIA GPU, I want the latest Intel processor. So having an architecture that's flexible to accommodate that while talking about the reliability things we've talked about and being rugged, this whole ruggedization that I've talked about, and for those of you that have time, we're actually out at booth 1616, so you can actually see some of what I'm talking about that we do to actually commercial off-the-shelf components you could get at Best Buy, but we turn and burn them to make sure they survive in the boot of a car in a very reliable and safe way.
And we touched on this a bit. How are we and how should we measure reliability? And is disengagement the optimal metric for evaluating reliability, or should performance under test dictate reliability?
Well, I mean, talking about California, for example, so disengagement can mean two things. It could be a good metric. It's a good metric if you're all testing under the right environments for the same purpose, right? Then it could be a reliable metric. The problem is you're not necessarily testing under the same environment and conditions and, for the same metric. And two, you want disengagements often because that means that you're pushing the envelope of your operational design domain in your equipment. So if you're not pushing the edges of that, then what are you really testing? So it's kind of like a child testing the patience of their parents to learn their boundaries. If you're not doing that, you never grow, and that's the same thing with an automated driving system as well. So the way that it is done now is it's not really a good comparison. It's not apples to apples. For example, Waymo's lack of disengagements compared to, say, GM's may not be a meaningful comparison, but there's no way to know whether that's a meaningful comparison or not.
I think the technical community has a responsibility to sort of go back to basics on this one, because there are well-established definitions for reliability, and I think if you just come up with on-the-fly ones, they're never going to be satisfying. But some of you may have heard the opening talk this morning by the number 2 person at the FAA, and he was talking about what they're doing in the autonomous space. But what he said was that, the FAA doesn't ever want to be coming up with standards per se. They want to adopt standards that are produced by organizations like SAE and go with that, because it gives them a much more solid foundation. And I think in the SAE documents that are already there now, there are quite nice definitions, and those need to be looked at carefully, and I think would inform a good decision about where to go for key metrics.
And let me jump in here. One of the things we haven't touched yet is the extreme secrecy among the vehicle manufacturers, among the sensor makers, which makes it really incredibly difficult for, if you're on the public policy side, trying to understand how you compare one operator in your city versus another. I come from Pittsburgh, and it's been described as a city that lives in 3 dimensions. And if you've ever been there, you'll know that there's a lot of up, there's a lot of down, and good grief if you know how the roads are going to get you from point A to B without ways. But the point is, for the most parts, the vehicle manufacturers are not, unless they're being compelled wouldn't be the correct word, but unless they're sharing that information with the cities don't know where those vehicles are operating. So, you may have one vehicle manufacturer that out of necessity, needs to go down roads in this certain neighborhood. Another vehicle manufacturer says, hey, we're going to see if we can combat the Pittsburgh left, that famous driving procedure that just drives people crazy, and we'll go through most of the city. And so I think that the industry, while we say we've got standards we can look at, while we've got best practices, I think they have to go back and have a little bit more disclosure about how those vehicles are being used, so we can start that apples to apples comparison. And frankly, this whole disengagement discussion is out there because that's the only crazy metric that people can rely on while maintaining all the secrecy that needs to go on to get their vehicles tested in Series B funding and in Series C funding and go public with their car.
I think you really touched on a really important point, and I can't help myself but mention that one of the lessons learned from the vehicle health management space is that there's really a desperate need for information sharing, better information sharing between suppliers and OEMs or integrators. And I think that lesson would carry over equally well to the autonomous space as well. But in particular, the consortium that SAE is trying to create, it's called Health Ready Components and Systems. There's actually a flyer in the back row of seats there if you're interested. But that is all about improving the sharing of information to allow people to do a better job at vehicle health management. That is, there's certain things that the OEM can try to reverse engineer the component or guess what the supplier had in mind, but that'll never be a substitute for good collaboration and cooperation between those 2 entities. So I think that's really a key point, and it's one of my major lessons learned in my experience with VHM. So
I think maybe to add on a little bit to what Ken was talking about, right? Just disengagements as a metric. The other primary metric are the number of miles that are driven. But another thing that we don't talk about in terms of discussing the operational design domain, the quality of the miles that are driven. So are those miles being driven in the city? Are they being driven on a highway? Are they being driven in inclement weather conditions? And that's another thing that, in terms of conveying that information, if you're just looking at a scoreboard and saying, well, Waymo's driven more miles than GM, has driven more miles than Daimler, that doesn't convey all of that information and get you to the point where you can make that judgment call about the safety or the reliability of their vehicle network.
That's great. And that brings up, testing. It seems as if many of the companies engaged in the development of automated driving systems are coming to the realization that they should have been working as hard in parallel on common testing to ensure commercialization and acceptance of those systems. Are you finding that to be the case? Everybody's kind of doing their own?
Yes. Yes, I find that to be the case. It's everyone's been testing on their own, again, most assuredly in secret. especially in this country, less so in places like Germany. And we've been at it for, I think, a short while in comparison to say, like Germany. But investors and corporate leaders are pushing for commercialization, commercial release of vehicles. And so they kind of now come to this point where, oh, wait a minute, we don't really have any regulations, insurance schemes, assurance from the public, common testing procedures that to accompany essentially what we believe to be ready or soon to be ready automated driving systems. And so I think we're seeing right now, from the SAE's perspective, a flurry of activity and willingness from previously reticent stakeholders to now participate in these sorts of activities, whether it's through our Automated Vehicle Safety Consortium or the International Alliance for Mobility Testing and Standardization. We're getting some of even the same names for both of them. They're sort of on different ends of that spectrum. But these are companies that either wouldn't even talk to each other together, wouldn't sit down in the same room and talk about working on things. Now that conversation is happening, but we now need to essentially catch up. 3 years worth of not having common dialogue and discussions about this, and in an environment, in a situation that is far more complex than I think some of the stakeholders either thought or led people to believe it was. So,
Yeah, interesting.
Here's another example from the VHM space on testing. As I mentioned, it's on several million cars right now. And one of the things that amazed me is that we would get to over 100,000 cars of a particular kind being monitored, and we'd still run into new corner cases. Corner cases are these basket cases where odd things happen and you don't quite know how to interpret them. So you need really large samples in order to get that testing done properly. And I'm reminded of a story this morning I heard in the keynotes that on one of the tests they had a raccoon walk across the street in front of an autonomous vehicle. And it's almost humorous, but who could predict that? I recall Apple once showed an example where the car had actually stopped, but didn't know why, but there was a squirrel in front of it, and it was being chased by a lady. I guess it was a duck that was walking across the street, but it was being chased by a woman in a wheelchair, electric wheelchair, who was following it around, and the car had no idea what was going on, but fortunately it stayed there and waited till they left. But this testing is a big problem, and you need very large numbers to do a good job.
Well, I'm thrilled to see a question from the audience. If you don't mind introducing yourself.
Yeah, so my name's Andrea Shestopalov. I'm from Aeros, which is a part of GE Aviation. I just, I come from the UAV side, so this question is maybe a little forward thinking, but when you get to fleets of autonomous vehicles, even their ground vehicles, is there any work being done to look at cybersecurity for the fleets of vehicles and, from a safety perspective, and also data privacy?
Great question.
yes, we SAE produced the first standard for vehicle cybersecurity. I want to say 3 years ago now, J3061. And that is recently I think it's in ballot right now. There is a joint working group now with ISO to produce an ISO SAE version, the next version of that cybersecurity document that is much more prescriptive. J3061 sets out sorts of principles and general processes to go through to ensure a cybersecure supply chain and componentry. The next revision of it, again, coming out hopefully any time now, will be more prescriptive in terms of the detailed steps behind that.
I would add that we have customers asking for help now. And as I shared in my introductory comments, we're doing a lot of work on the military side where cyber is a really, really big deal. So we're actually able to implement some of those things now, like on the board level. Things as seemingly simple as anti-tamper, anti-intrusion componentry is important. So we're bringing some of that knowledge into the space while trying, as the specifications are being rolled together and put together, we're trying to bring some of that experience into some of those forums as well. But Make no mistake, I think that's a big deal for everybody to be considering that in their system architecture. And we're going to talk about 5G in a minute here, but I think that also brings another potential vulnerability from a cyber that we need to be aware of as we're architecting a broad system solution.
So you not only mentioned the cybersecurity, but also the privacy aspect. And one of the underlying aspects for privacy has to do with who owns the data. And in the aerospace industry today, that's a huge problem. And everybody wants to own it and everybody wants to sell it. And that leads to particularly troublesome behavior and causes problems. So I think in the end, I hope that the person who owns the asset will own that data, and that'll point the way to how to best serve the needs of the customer. But it's really a big problem right now.
Yeah, and I love that question because I'm going to pull my crystal ball out here. So in every encounter I've had with a systems manufacturer, component maker, cybersecurity ranks up there as one of their top concerns. So I think it's an industry that is very appreciative of the understanding that cybersecurity needs to be baked into what they're doing. If nothing else, for solely internal purposes, they don't want to have the component that's hacked into that damages their brand. But here's Ken's crystal ball on all this, and the crystal ball says, be careful what you ask for in terms of regulatory involvement with cybersecurity, because then that's going to become the lowest common denominator of cybersecurity. And that's, I think, a place we don't want to go. I think that's what the airline industry is battling right now. On one hand, they want to have standards for cybersecurity. They've got a big batch of standards across, probably 7 or 8 different standards organizations that have really good practices. But then that forces them to choose which standards are better for us. But if you have the regulators saying you will choose this standard from that organization and that standard from that organization, then you're kind of protected by the regulation and you're not really upping your game. You're just meeting the lowest common denominator. And I think we got to understand on the automated vehicle side, where do we want to be? Do we want to have the lowest common denominator or do we want to exceed that? And I would say one other cautionary tale, and I know that the automotive industry has a rich history in standards, but if you look specifically in drones and all of the thousands of standards that have been written by standard organizations, as far as I know, only one of those out of ASTM has ever been adopted by the FAA. So you got to work with the regulators if you believe in those standards and get them adopted.
I want to come back to your point on privacy for a second, because really what you're seeing play out in the AV vehicle space is this sort of tension between Detroit and Silicon Valley. And Silicon Valley's model, and they're unabashed about it, is they're going to find value in the data. They're going to take the data set that's generated by the vehicle and by the transportation network and use that in some way, shape, or form to create more value. Where it seems like Detroit, maybe Europe, their models are a little different. And so I think what you're going to see in the next 10, 15, maybe 20 years is how that tension plays out between the two groups. We've already seen BMW basically open their data platform, their open data platform, and provide that data to anyone that's interested in it. And anonymize that data in a way that makes sense, so that they do maintain their customers' privacy.
That's great. And to that point, I was listening in on a panel on urban air mobility, on-demand mobility, and the gentleman from Bell stressed, and this is the first time I had heard it, but stressed that the goal is to move goods, people, and data. So that's definitely part of the plan. All right. Now, more about testing. Limiting the operating environments of autonomous transportation is a popular method of testing reliability right now. Is it enough to ensure safety and reliability? Are tests on public roads essential?
Could be yes, and also yes. If limiting the domain or where a vehicle or system is able to operate is inevitable inevitable happening. I mean, you know, we have our levels of automation. There are good things, bad things about them. One of the things that I think people should understand is that level 5 automation, which I hear people say all the time, oh, we were developing level 5 systems. And I say to them, no, you're not. And then you don't understand level 5. Level 5 is like infinity, right? And it's infinity we may never even want to get to, or have a meaningful economic reason to get to, or practical reason to get to. It is that which we say this vehicle can operate in any operational design domain without any driver intervention, you know, whatsoever. Everything really is going to be at that level 3 and level 4 area in practicality, and that means limiting in some way or defining what the limits are of that operational design domain. So that's the truth of that matter.
One other point, often the way that restricting the domain is actually practiced is to make it more reliable by honing in on a geographic area or something to improve the reliability. But I can say from my entire career, which has been involved with automation, it's always, always good advice to try to structure the environment to the maximum extent you can. And the typical academic viewpoint, which often becomes the popular viewpoint, is let's be as open and flexible as we possibly can. And that's a recipe for disaster. So whenever you can cost effectively, reliably put in beacons or structures or some sort of aids into the environment, that massively improves the likelihood of it being successful in real life. So I think it's always a good idea to do that.
And one of the trends we're seeing is that our regulators are getting more sophisticated as time goes on, and it's almost exponential. One of the discussions we've had over the last couple of years has been around the environmental factors that could affect the machine perception systems. And so now we have discussions at the state and local level about, are these manufacturers testing in the same environmental conditions that we actually experience over here? And there's been several interesting studies out of Carnegie Mellon that suggest that, especially for optical systems, if you reduce the quality of that scene by as little as 5%, you're going to lose a lot of the image detection that you have. And that message has gone to the regulatory community as well. So the number of questions are very sophisticated. It's not just, you know, driving this geographic box, but hey, have you driven in the fog that comes off the river? Hey, did you know that there's a power plant here that tends to have emissions that go across these roads? And so I think while the advice is absolutely well heard from my colleague here, that you have to really define the parameters you're in, expect that you're going to face a community that is going to understand the importance of that perception system and the things that can, you know, metaphorically cloud its picture of the world.
Along those same lines, just to follow up, think about the number of sensors that are required to reach level 1, level 2, level 3 autonomy, and start thinking about the number of sensor systems, optical or otherwise, that have to be carried on the vehicle. How can you ensure that those are going to stay clean and operating properly throughout their normal service life? Then you start talking about the cleaning modalities that also have to be carried on the vehicle as well. The weight that's required is enormous. And so if you're talking about this along with vehicle electrification, so then you run into issues of range. And so these are the things that, you know, 3M is really thinking through how they play on one another and what things we can do to help mitigate or improve the operation of those sensors in those conditions. So whether just small droplet formation on a LiDAR unit, right? You are going to scatter that laser. That is going to happen. So what are the deleterious effects of scattering a laser beam off of a LiDAR unit? Does it mean the difference between being able to detect a child running in the street? Does it mean the difference of being able to detect a vehicle that's come to a sudden stop 300 meters in front? And it depends on the way that sensor system has been implemented. and the other sensor systems that are complementing that one sensing modality, right?
I wanted to, just your second question too, which is, you had two questions in this. I think the second one was about on-road testing, is it necessary? So on-road testing is what we say uncontrolled environment. You don't know what's going to happen. You're not controlling all the conditions. You might control some of the conditions. You can choose the roads. You can choose the time of day. You can choose the weather, that sort of thing. But still, a lot more things can happen. That means two things. One, you could be doing a lot of testing, waiting for something to happen, and to do a very specific test for a specific condition, you need to do that in a virtual or a physical environment or a cyber physical environment. So that requires, closed test beds where you are controlling the scene and all the environmental conditions and equipment and the actors involved in the situation or scenario, or virtual environments that's the same. And so the typical testing is you do it in a virtual environment first if you're making a change, because you can do a lot of testing very quickly, and it's cheap. Physical test beds are always going to be the closed test beds are always going to be the most expensive, but you can really test the edges of your scenario in a scientific way. And then in an open environment or a pilot test on the road, you're basically seeing if there's anything out there that is unforeseen that you did not account for in your physical test environment or your virtual test environment, that, I got to go back to the drawing board. That makes sense.
That's interesting. So I heard optics, I heard sensors, I heard LiDAR, so here it comes. Actually, I'll start with, so I've heard from the AV community that the MCAS challenges that Boeing has been experiencing is really impacting, the automakers and ADAS developers. Are you guys finding this to be the case too, trusting sensors and optics and if it's feeding the correct information? And
Absolutely. So at this point, I can relate a personal story. So 3M did a partnership with the Minnesota Department of Transportation last year to bring an autonomous vehicle in conjunction with the Super Bowl and operate it on public streets, and then operate it in their closed loop testing environment that they have just north of the Twin Cities. And the very first day of operation, they brought the press to come see the vehicle and offer rides to them so that they could, start to kind of get the word out and understand how these systems were going to operate. There are 4 LiDAR units that are on the corners of this particular vehicle, and sure enough, it's Minnesota. It started snowing that day, and the vehicle, which normally operates anywhere between 10 and 15 miles an hour, slowed to an absolute crawl. It was only about 3 miles an hour operation because of false detection of the snowflakes as objects in the environment that should be avoided. So it sent the vehicle into a lower mode of operation in order to keep their safety factors up. And so we saw this play out actually on the videotape with the media as this autonomous vehicle is moving very, very slowly through the environment. So all of that is to say that the sensors are important. When you get false detection, some things can happen. And as the case of what we saw play out with Boeing, here's another sensor. We're learning more about the reliability history of that sensor. And I think as more information comes out, you're going to start, we've already seen it start to cross domains. So going from the aerospace industry, and now it's impacting the way that people understand autonomous vehicles, and the association there is autopilot. So when you connect the word autopilot in the aerospace industry to autopilot in the automobile industry, you've immediately made that connection in the consumer's mind. Hey, these sensors are important to both systems, and when they're not functioning properly, people can die.
And we've talked about redundancy before. Another kind of redundancy is to have multiple sensor systems that somewhat overlap in their functionality, and therefore, when one is weak, the other is strong. So you really don't want to limit yourself on incoming sensory information, because that will definitely impact your survivability and long-term reliability.
And for those, that may not understand sort of how sensors work in the aerospace industry, generally you want three components, or sensors providing information in redundancy. Because if two disagree, you don't know which one is right. If 2 out of 3 agree and the third one disagrees, okay, well, I know that third has got a problem. And your probability of 2 sensors failing at the exact same time is far, far lower. But that's a good lesson for automotive too, especially for driverless vehicles.
Great. We have a question in the audience. If you don't mind taking the microphone, please.
So the name is Edward Schwalb. I'm from a simulation company, MSC Software. The question is a little bit complicated related to the topic of sensors and the complexity of testing and so on. So the topic I'm trying to raise awareness of, sorts or ask about, is if you look at the work in ISO 26262, for example, it's about vehicle failure. The discussion here is about redundancy for the vehicle, make a vehicle reliable. But if you look at the NHTSA statistics for number of accidents because of the failure of the vehicle, you will find out 0.7%. There is going to be about 30% because of the driver, single driver cases, and 60% because of 2 drivers, and about 6%, remaining 6% is about more than 2 drivers. And in one example, which I can illustrate, there's a notion of a vehicle following another. So you're doing ADAS, like we all have, like we have millions of cars now having advanced driver assistance where we do cruise control. And if we are following a vehicle that's making a maneuver, like moving to the right, the vehicle we are driving will not have enough time to brake to avoid an accident with an obstacle avoided by the vehicle that moved to the right. It's a very common occurrence. It happens, according to NHTSA, more than 1% of the situations, and we already had Tesla accidents such as that. Now, the points to be made here is this is free vehicles. It's my vehicle, it's the vehicle in front, and the vehicle that's stopping because it's waiting for pedestrian, or maybe there's a tree on the road or pothole, whatever it is. Now the complexity of testing and reliability is no longer a single vehicle. So when you're talking about a human driver, standards are about, FMVSS and otherwise, safety as per for the driver for individual vehicle. But when you go to autonomous driving, even level 3, even advanced driver assistance, the rules are now you have to take into account multiple vehicles. And now my question is, how do we make the community start to handle and address at the standards level, at the regulation level and such, the notion that we have to handle multiple vehicles as part of our metrics?
Thank you.
I think that's developing. So, the AUVSI consortium, which is an OEM-based consortium, I think is going to probably try to tackle some of those issues. I haven't heard it phrased exactly in that way before, but I agree with you. I think part of the difficulty is a misconception about what an automated driving system is. Often people think of them as a vehicle, but it is really a driver. It is a driver that we're now dealing with here, not necessarily a vehicle. There are vehicle components, obviously, that are in it that need to be reliable, but we're talking about driver behavior now. That is, so it's not, again, the 0.7% vehicle issue, it's the 20% driver issue. Now that we have to, yeah. Okay, but so it's a driver issue that we're now worried about, and how we handle that. That's a good question, because that equilibrium of how many vehicles will be at what level of automation versus vehicles that'll be manually driven. We probably won't reach that level of equilibrium for, I don't know, 40, 50 years, maybe. So there's going to be a whole lot of mix of vehicles of different capabilities and different levels of automation or no automation up until that time, where multiple vehicles of different types need to be considered.
This isn't my area, but I'm sure you know there's an enormous initiative on connected vehicles in automotive, which has as a primary purpose exactly what you talk about, that each car would know where all the other cars are and what their velocity vector was, and have information about what their movement is and their intent. to help avoid those kind of problems, I think, at least in part.
Fantastic, thank you for the question.
Yeah, I mean, part of the challenge, vehicle connectivity will provide, I would argue, as much or more safety than a fully automated vehicle, right? If you have vehicles being connected, they know their environment, and they know the environment of other vehicles, and the infrastructure as well can communicate back and forth. That is such a challenge right now, because that sort of system doesn't become super meaningful until you reach, a critical mass. You can have an automated vehicle, so it's easier for me to develop an automated vehicle that can, sort of run on its own from, say, point A to B. It is much harder for me to commercialize a connected vehicle when I've got nothing else to connect to it, and there's no, information sharing that it can take advantage of right now.
Great, another question from the audience, please.
Yeah, so when we were talking about sensor redundancy a moment ago, I think we mostly focus on the sensors on the vehicle. In aviation, there's always a combination of onboard and ground-based sensor. Are there any plans to do any kind of infrastructure, ground-based sensor work to supplement the sensor technology for autonomous driving?
Absolutely. So another thing that we've been looking at is the pavement markings and signage that are in the environment. So there are some methods that we've developed that will allow us to embed machine-readable codes within a sign so that both humans and machines can share the same infrastructure, essentially. Along with some pavement marking systems that are higher contrast, both for humans and for machine vision. So the primary issue that we're trying to consider in all of this is, at least in the US, what kind of infrastructure spending are we willing to do, right? We have a basic roads maintenance issue in this country. How much more are we willing to put into this to enable autonomous vehicles? We still need to keep human drivers on the road as well, right, with functioning infrastructure. So other places, they're a little bit more willing to invest in their infrastructure, and so I think they're starting to prepare themselves for self-driving vehicles by upgrading some of that basic infrastructure.
So the ways you just suggested, by creatively enhancing the tools that are already there in the environment, seems like a very good direction. Some people have talked about elaborate instrumentation on the roadways themselves, and there the costs can get as high as building the entire interstate freeway system. So that's probably a cost that, like, the U.S. government could never afford to pay these days. So I think we need smart ways to get that in, but anything that we can do that enhances structure to the environment is going to be really valuable.
And I don't think that's a fully developed question yet that, the greater infrastructure community is tackling. I mean, they don't know that there's LiDAR-friendly paints and perhaps LiDAR-unfriendly paints. They don't understand that some reflectivity off of certain structures is bad. So I think we have to start getting the architecture community, the civil engineers to have that, because I think while that's not going to stop self-driving, I think it's not going to allow self-driving to really blossom to the way that we think it needs to as an industry and get to those incredibly high figures that we see about how this is going to be a multi-trillion-dollar economy someday.
Oh, another question, please.
Hi, my name's Andy Latcher. I'm with the MITRE Corporation. You talked about disengagements and miles driven as being the data, or the coin of the realm in terms of comparison, because that's what people are sharing. Having been involved in some nascent efforts regarding information sharing among 6 OEMs regarding some ADAS features, one of the challenges is everyone collects different information, and it's not only in different formats, it's totally different. And even some of the things, even just whether the ADAS feature was on or off in the vehicle is not collected. And so we can't analyze the performance of these features because the data doesn't exist. And we've made some attempts to try to instrument vehicles ourselves, and each manufacturer is different. So we have to engineer a different solution for each manufacturer. So to me, this seems like an excellent opportunity for the standards community to standardize the data that should be collected, even just on deployed ADAS features. So thoughts on that?
So, Andy, can I jump in here? I think there's a question that precedes the one that you just asked, and that is, what data informs public policy and public policymakers so that there's something actionable at the end of collecting the data? I think, as you know, we live in a world where there's just too much data right now. And I don't necessarily know that the industry has been proactive enough in saying, hey, you know, this specific information that we collect from these specific sensors will make you do a better job of developing public policy to allow those vehicles to operate, to determine what streets they can operate on, because that's what the local municipalities are thinking about. That's what the states are thinking about. And you know, you've got the overriding structure from DOT that essentially says to local entities, thou shalt not. But in reality, they're saying nobody knows our cities better, and you know, whether it's through the municipal, you know, let's work on some guidance for that and say this is the public policy we need, and then we can, I think, identify the data that could support that.
We do have, at SAE, we have a data recorder committee that works on data recorder issues. And I know that there's some, I don't know the number of the document, I don't believe it's published yet, but I think there's something coming out to be some sort of, at least minimum set of some basics. I don't know a lot of the details, though. It's not my level of expertise, but I can talk to you later and find out more.
By the way, as an analyst, I would never say there's too much data. So.
Fantastic. Well, we've come to the close. I want to thank our panelists. Thank you for attending. Thank you for your thought-provoking questions. If you don't mind giving them a hand. Into 3 o'clock, just right out in the hallway. Thanks again.
Perfect. That's the fastest hour of my life.
Really?
What happened? Oh, yeah.